this somewhere?
No, I'm just, do we get the surface area if it's sphere?
No.
Please.
I would probably give you that one.
Love you.
I wouldn't give you like area of a circle or anything like that, but surface area would. Okay, so on 3, we have the altitude of a triangle is increasing 3 centimeters per minute, while the area is increasing at a rate of 4 square centimeters per minute. We need some variables here. You're welcome to draw a triangle. It doesn't say it has to be a right triangle. If I'm talking about the altitude, what is that? The height. So I'm going to call that h. So this is my h. So it tells me that's dh dt. It's increasing, so it is positive 3. The area, so usually area is capital A, so dA dt, is increasing 4. At what rate is the base of the triangle changing? So if I'm looking for my base, I'm going to call that dB dt. I'm looking for the rate, so that's why I know it's the derivative. That's the thing I don't know. When the altitude is 10, so that means the height is 10, and the area is 90. So that's the stuff I have. If I am going to use these derivatives, h, a, b, what formula am I using? The area of a triangle is 1/2 the base times height. Okay, so if you do this derivative, keep in mind, b and h are both variables. So the derivative of a is dA dt. But if I'm doing a derivative of 2 variables being multiplied together, what do we have to do? Product rule. So derivative of the first, derivative of 1/2 b would just be 1/2 dB dt times the second plus the first, so 1/2 b. Derivative of the second, derivative of h would be? Alright, a lot of times we are trying to simplify before we do our derivatives so that we don't have as many variables, but here I needed to keep all of them because I'm asking about all of their derivatives. Okay, we have dB dt, we have dH dt. The times when we try to get rid of it is if I don't give you any of the information for one of those variables. Alright, so then if we plug in dA dt was 4 equals 1/2. I don't know dB dt. Can I reorder this? We have to, our h was 10 dB dt plus 1/2. Do I know my b?
No,
Okay, my dH dt is 3. I'm trying to find dB dt, so I don't need any other variables. So we have to find the b, but we can, because we know the area is 1/2 base times height. The instant we're looking at, the area was 90, equals 1/2 times b times 10. So our b there is, not 45, because I'm dividing by 5, not 2.
Oh, I did the same thing. I was
18.
wondering how on earth I got 45 by 18 and
And so this is 18. So we have 4 equals 5 dB dt plus 1/2 times 18 is 9 times 3 is 27. So if we subtract that over and divide, so dB dt is negative 23/5. For units, B is in centimeters, T was in minutes. So it's a negative because it is decreasing at that instant. Oh,
I think I understand.
negative 4.75?
negative 4.6 is what the
Oh, yes,
what the
sorry.
calculator gave me.
Negative 4.6 is correct.
Yeah, no, yeah.
I understand.
It's okay.
So you had it. Yay, we knew what we were doing.
It's okay. 'Cause I won't
Well,
do it.
it's good for us to review.
Yeah.
All right. Anything else on that first page you want me to talk about?
Cause like, I like my homework days, you know? Homework days are nice, you know,
I like passing my test.
you know?
So,
It's like 80% of my grade.
problem 4. A balloon is rising at a constant speed of 5 feet per second. So we have this balloon, and I'm very artistic, so here's my balloon.
She didn't even start drawing. Oh, I thought you said her picture was.
Oh, I did think
I
you
drew
were
a
going to
really good
compliment.
bike.
Your picture is amazing, but I didn't see you explain his, so I thought you literally drew a circle. He's like, your picture is amazing.
I mean, it was a good circle, you know. Okay, so that's rising. Is it the same all the time?
No.
No, so this is a variable, so it'll be a y. Alright, if I'm telling you how it's rising, then that is dy dt, and I told you that was 5 feet per second. Alright, a boy is cycling along a straight road at a speed of 15 feet per second. So the boy is coming here. It says when he passes under the balloon, it is 45 feet above him. So he's riding along, he's going to go under it, and he keeps riding. Okay, so here's my boy. I'm going to pretend he's running because I'm not going to draw a bike. So
He's on a little unicycle.
his speed is 15 feet per second. So this has to be a variable. So if I call it x, that means dx dt is 15. We want to know how fast the distance between the boy and the balloon is increasing 3 seconds later. So here's the boy. Here's my balloon. This distance is changing, so it's another variable. So if I call it z, dz dt is the thing I am looking for. Okay, so we started at time 0, y was 45, but I want 3 seconds later. So if it started at 45, and every second it goes up 5, in 3 seconds, it started with our 45 plus 5 times 3, so we had 15, and y is going to be 60 at that instant. X, so here's like where he started. In 3 seconds, where would he be? So he goes 15 feet every second, so for the 3 seconds, x is 45. Are we going to need z at the same point?
Might as well.
Might as well. So, we know x squared plus y squared equals z squared.
75. Oh my gosh, it's 2025 right now, guys.
I don't know why that was just.
Okay, so we have x, y, and z for that particular instance. Are any of these constants?
No.
No, they are all changing. So when I go to my formula, x squared plus y squared equals z squared, and I do my derivative. Derivative of x squared would be derivative of y squared and derivative of z squared. So then we plug in. X is 45, dx dt is 15, plus 2, y is 60, dy dt is 5, equals 2, z was 75, dz dt. Alright, so everybody's following here? So if we divide, we get 13. Alright, Z was measured in feet and T was in seconds. So the distance between them is increasing 13 feet every second.
So we can't have calculators for that. But it's gonna be a lot nicer, so we won't do that. We could have done that one. We could have done that without a calculator.
Yeah.
Nah.
No,
Yeah,
I
'cause
didn't.
on the a squared plus b squared equals c squared, they're just multiples of 3, 4, and 5. I'm saying I could, you probably.
Yeah, Carson could have, but I could not have.
Alright, so this one's okay?
You see on my test, I write out my multiplication.
I do that. I do like 16 times 4, and I'm like, I should know this, but
I know it's 64, and I think about Minecraft when I do anything like that.
So number 5. A funnel in the shape of an inverted cone. So we have our upside down cone. Is 30 centimeters deep. And the diameter is 20. Now we never use diameter. What's this giving me?
Radius.
The radius would be
10.
Okay, liquid is flowing out of the funnel at a rate of 12 cubic centimeters per second. When you see that cube, what am I giving you? Volume. And since it's a rate, this is dV dt. If it's coming out of the cone,
It's decreasing.
so our volume is negative 12 dV dt. At what rate is the height decreasing? So we are trying to find dHdt. At the instant when the liquid in the funnel is 120 centimeters deep. So at the point when the height is 20. Alright, so volume of a cone is what? That's a
One third pi r
squared.
R squared H.
Okay. Looking at this, we have a problem. If I do this derivative right now, then we are going to have dv dt, dr dt, and dh dt.
We don't have the R.
We have no information about r. So I need to get rid of the r before I do my derivative. Okay, we've seen a few examples like this now. Probably going to see one like this on your test tomorrow.
Oh my god.
Hint, hint. Not that I were to ever give you hints, but if I did, I would tell you there's probably a question like this on your test.
To make 2 triangles.
Okay, so we know that overall my height is 30 and my radius is 10. And I am looking at this one. We need a relationship between the height and the radius. Okay, so we can set up a proportion. 30 over 10 equals h over r. We're trying to find what r is. So r is 1/3 h. Okay, so I use that ratio, those similar triangles.
Because the whole cone is 30.
Oh, I wasn't doing, like, that would give you the radius at that point. But I was just trying to find in general how are the radius and height related. So I just did the entire cone. That would give you the number to plug in for r later, but it wouldn't help us get rid of r in the original equation. So remember, we don't want to plug these things in until the very end, those numbers that are changing. So if I use this, that means my volume, 1/3 pi, I'm going to write that as pi over 3. My radius, 1/3 h squared times height. 1/3 squared is 1/9 h squared. So volume is pi over 27 hg. So on your test, can you get rid of that radius before doing the derivative? So now, if I do this derivative of v would be dv dt. Pi over 27 times 3 would be pi over 9 h squared dh dt. dv dt is negative 12. H is 20. 20 squared is 400. So, at this point you can divide it over, or if you multiply by the reciprocal. So the HDT would be 27 over 100 pi. And then our units, H in this problem was centimeters and time was second.
Will the pi always be on the bottom?
If you're dividing it over. Is that one okay? Problem 6. The circumference of a sphere was measured to be 90 centimeters, so C equals 90, with a possible error. So when I'm talking about error, we label that DC. So this is no longer with respect to time, this is error. So that's our differentials. Use differentials to estimate the maximum error in volume. So error in volume is dB. Okay, we have a sphere. If I want volume of a sphere, what is that? Surface area is 4.
I looked at my derivative and tried to work backwards
Oh.
and it didn't work.
Gotcha. So again, on the test, I will give you basic formulas. So surface area, volume of a sphere, I would give you. Volume of a cone, I would give you. If it's like area of a rectangle, triangle, circle, you should probably know those. Pythagorean theorem, you should know that. I won't give you those. But okay, so if I want this, what do we have to do? Derivative. So when I do this derivative, so the derivative of v, if I'm doing differentials, becomes dv. 3 comes down, so it's 4 pi r squared. This would be dr. So here's the problem. I have dv, but do I have any information about r or dr? No. So we have to take a little detour. We're stuck. The other information we have is about circumference. Circumference is 2 pi r. So if my circumference is 90, divided by 2 pi, the radius is 45 over pi. So now I've got part of this. We need dr. So that's where the differential for circumference comes in. So the differential for C is dc equals 2 pi dr. We know that dc is 0.5. 0.5 divided by 2 would be 0.25 divided by pi, or 1 over 4 pi. So you could have 0.25 over pi or 1 over 4 pi. So now I have my deal. Are we okay with that? And now we just work this out. So do these cancel. So 45 squared over pi squared. My units volume is cubed. We were in centimeters, so centimeters cubed. And it's not in terms of time, so I don't need a per second or anything. Alright, so that one was more involved. That's where all the labeling is very helpful. You're writing all this stuff down. You know, I will give you points for knowing what variables you have, for plugging them into your formulas correctly. So make sure you are keeping track of that.
How come when I put that into my calculator, it just says 2025? It doesn't do it over pi squared. Unless I just put it through
Yeah, this 4 pi to be in parentheses.
Well, I say that like I need to use a calculator.
But maybe I'm lying to you, so it's good to know. Alright, then we got into some of our linear approximations. So, linear approximations, it's like writing the equation of the tangent line. We want to approximate f of x equals the square root of 7 minus x at a equals -2 to approximate the square root of 7.1. So if a is -2, we plug that in, that's 7 plus 2, so the square root of 9 is 3. So that's a point. To write the equation of a line, we need a point and a slope. How do I get my slope? Derivative. Keep in mind, the square root is like a 1/2 power. So our derivative, exponent comes down, inside stays the same, subtract 1 from the power, times derivative of the inside. Okay, you can leave it like this. I always rewrite it because I need to plug numbers in. A -1/2 is a square root on the bottom. So that's my derivative. So my slope is when you put -2 into your derivative. So we get -1/6. So now we have a point and a slope. So y equals m times x plus b. So 3 is like 9/3 minus 1/3 is 8/3. So the linear approximation, L of x, is -1/6 x plus 8/3. Now we are trying to approximate the square root of 7.1. Because my original function was the square root of 7 minus x. I'm trying to find the square root of 7.1. We have to figure out what x is. So if 7 minus x is equal to 7.1, so we have to do the linear approximation of -0.1. So if you plug that in, 1/60.
2.68.
So you would obviously on the test without a calculator, are you probably going to be able to approximate one? Not unless it was really nice.
Maybe I just don't remember, but why did we do like a 7 minus x equals 7.1?
Just because this particular function wasn't just the square root of x. There was something under there. So if I'm asking you to find the square root of 7.1, 7.1 has to equal to 7 minus x. So most of the time we wrote our own and we just put x under the radical, so we didn't have to worry about it. But if I gave you that function already, then we had to use it. Okay. Number 8. approximation to estimate 83 to the 3/4 power. So this time we have to do everything. We need a function and we need a point. This means the 4th root of 83 cubed. So my function is just probably x to the 3/4 power. My point has to be something close to 83 that we could actually work out. So what's the number close to 83? 81. What's the 4th root of 81? The 4th root is 3 to the 3rd is 27. So there's my point. Slope, so we need derivative. 3/4 x. If you subtract 1 from the power, it's -1/4. Or if you want to rewrite it, and negative means it's on the bottom. 1/4 power is the 4th root. So to find our slope, if we plug 81 in, 4th root of 81 is 3. And we get a slope of 1/4. So now y equals mx plus b. So the linear approximation is 1/4 x plus 27. And this time we are trying to approximate 83. So we need to do the linear approximation of 83. So 83 over 4 plus 27 over 4 is 110 over 5 over 2 or 27.5. What?
That was a square color.
Professor.
Oh, I got that right. I just
Thought you had it wrong?
I added it as a fraction.
Oh.
But I
Yeah,
definitely
55
put
over
it in.
2.
I definitely put it in the calculator again, so that's wrong.
That's fine.
Imagine you took calculus classes and all they did was just work it out but not say a word. It just went pew, 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 and box
I've
it
had
in.
those professors. They're
I could
fun.
not.
Alright, problem 9, differential.
Deep ideas.
Okay. So differential is just your dy. We talked about a couple different ways. You're used to notation we've seen. We can call it y prime. We've seen dy dx. So that's all this is. If we do that derivative, the derivative of a natural log is 1 over the argument. So we have two chain rules. So times derivative of the inside. So derivative of x is 1. This is like x squared minus 1 to the 1/2. So 1/2 comes down. The inside stays the same. Subtract 1 from the power. But another chain rule derivative of that inside is 2x. From here, times 1/2 and 2 would cancel. So x minus 1 to the 1/2. The only thing you really have to do is multiply over the dx because the differential is just dy. You are welcome to rewrite this as much as you would like. That is totally optional if you wanted to move that onto the bottom. But the one thing you need to realize, the dx is multiplied by all of that. It's on the outside of everything.
Would can we move that thing onto the area of the other one, like that.
Yeah, if you left it as a negative 1/2 and put it there, yeah.
Like, no, I'm meaning like take the 1 plus x over x squared minus 1 and move that onto the
A
numerator.
fraction and a fraction.
That's illegal.
Well, I didn't do it as a fraction, I just kept the negative
Yeah,
x.
I mean, it's not great notation, but yeah, I wouldn't count off.
Oh, I didn't-
No, of course.
First time.
No,
How does that? Oh, because it's a negative.
You okay?
Yeah, I was trying to figure out where that fraction came from the last one.
Oh, I just dropped it down because of the
Yes.
negative power. So differential is just a derivative when you multiply over your dx on the end.
Oh.
All right. So marginal cost is derivative. You guys are all okay with that? We've seen a lot of these cost functions. Not that I ever give you hints, but we're gonna see one.
Bye.
Yeah, I mean, you guys didn't know that already. It's not like my study guides are anything like the test at
No,
all.
I've never had a study
No.
guide that corresponded
No,
to
it
the
doesn't.
test.
It's just a waste of time.
Yeah, it's busy work.
I'm big on that. Okay, so your marginal cost is your derivative. You guys can find c prime of 100. The explain its meaning. Make sure you recognize it doesn't tell me how much it costs to make 100 items.
It's increasing.
It tells me how the cost is changing. So it's increasing 10 cents when we are making 100 items. Okay. Then I want to compare that with the cost of producing the 100 first item, the real cost. So if I find the cost of 101 items, that means I go to my original equation and I plug in a 101. So do I have to write out that work? So if you plug that in. Okay. Now look back at part C, or on part B. We found C prime of 100. That's how the cost was changing. So I found the actual cost of 101. To find out how much it changed, what else am I going to need? I need the cost of 100 items. And if I plug 100 into my cost function, we get 990. So the actual change, you subtract them. So this is the actual change. The prediction is our C prime of 100, which we got to be 0.1. So we can see the actual cost was just slightly higher than our predicted cost. What if I had said what if I had changed this? If I had said use the cost of 100 items and C prime of 100 to predict the cost of 101 items.
You would assume the cost of my own would be 990.
Okay, we found the cost of 100 items is 990. Based on our derivative, we would expect the cost to go up by 10 cents. So then my predicted cost would be 990.1.
Not that one. That's not right.
So we could do it a couple different ways. We could find the true cost, or we could use it to make a prediction about our costs. All right, so is that okay? All right, number 11. We are getting a little short on time.
If we can just do, I'm okay if we just do C,
Okay.
and then come back to it if we have.
All right, let's just jump to 12 and then we'll come back to 11 and see what we can do. So on number 12, we make computer chips. And they are squares. So we know in a square, every side's the same. Pretend that's a square. And we want the x to be close to 15. We want to know how the area changes when the side length changes. Find a prime of 15. So first, what is the area of a square?
X times X or
X squared, x length times width, x times x. So, my derivative, you can call it dA dx, you can call it a prime of x. They're same notation, means derivative. Derivative of x squared would be 2x. So I asked you to find a prime of 15. So that means x is 15. We get 30. So that means the area is increasing because it's positive. Area is square units, so 30 square millimeters.
So would we not have like 2x dx?
No, because I didn't tell you how x was changing. I didn't even say that I'm changing x. I just wanted to know what was
So
happening
we
to the
add
area.
these dx's or we add these only when like there's time involved?
Mm-hmm.
Okay.
All right. So problem 11.
Wait, so it wouldn't be a dA over dx?
I mean, you could.
Okay,
It's the same thing. Yeah.
But not.
Not
DADT.
Right, because we're not doing it in terms of time. It's just with relationship to the side. There was no mention of time in that one. So 11, we have the height. Part A, you guys all know velocity is just your derivative of height. So that's your 15 minus 3.72 t. So you guys can plug in the 2, and that's where the 7.56 meters per second came from. We okay with that? B, the maximum height. So think about your height. It's a parabola. Anytime I ask for a maximum or minimum, what are we doing? The derivative equal to 0. We already found the derivative in part A. So we set that equal to 0 and solve, and you get t to be, I have 125 over 31. That's the time. I asked for the maximum height, so what do you have to do?
Time in this equation.
Mm-hmm. So we go to the original. And that was where I got my 30.24. Alright, so two things involved there. We had to know that maximum is when the derivative is 0, and then that gave us the time, and I wanted height. Part C. What is the velocity of the rock when the height is 25 meters on its way up and on its way down? So I want velocity, but the thing I know is my height. So we have to set our height function, the original, equal to 25.
Oh.
So we can get the times. Now, obviously, these numbers are not pretty. So on the test, I would have to give you better numbers.
Quadratic formula.
Yeah, if you set this equal to 0, so then you can do quadratic formula, so the opposite of b plus or minus the square root of b squared minus 4 times a times c over 2. That's where I got
Oh.
my 2.35 and my 5.7.
Crossword represent?
Huh?
Crossword represent?
Lots of emphasis.
Guys, do a word first.
Also,
What'd you say?
I goofballed because I made my negative 1.86. I kept it in the original notation and I didn't flip them back around, so I made that my b. Even though it's always a 'cause it's the squared.
Gotcha. That
I
would do
did
it.
take off points if I wrote, like, in the, under the radical, if I wrote 15 squared instead of negative 15.
No, that's fine.
I'm like, if I,
oh.
I didn't, like, I kept the negative 1.86t
Mhm.
on that side. and I did
That's
it,
fine. You
so-
can move everything to that side.
Okay.
Same thing.
Yeah.
So I wanted the velocity going up and down. So you had to recognize that going up was the smaller, the first, right? It's gonna go up before it comes down. Then coming down would be when I plug these. So then you're putting those into your derivative. And that's where I got the 6.258. And coming down, it should be a negative. So that's where I got those.
Oh,
Did you get
wait,
the C
what?
number on that?
Yeah.
You plug that into the
Negative
derivative, you said?
6.
Huh?
You said you plug that into the derivative?
Yes, to get the
Oh, I
velocity.
didn't
You had to
see
put them
the
into
way
the
down.
velocity formula.
Yeah.
I would have missed those points.
Does that make a little more sense? scroll down
Yes.
to word part D.
Yep.
D, if it hits the ground, what does that mean?
0.
The height is 0. So you set your original equal to 0.
T equals 0.
So if you factor out a t and solve, you get 0 and 8.06. The 0 is because you started on the ground, so it hits the ground after 8.06 seconds. And then F, or sorry, E, the acceleration. How do we find acceleration?
The second derivative.
Second derivative. So it's the derivative of the velocity. Velocity from part A was 15 minus 3.72 t. So this would be negative 3.72. And there are no variables to plug in. And F then the velocity when it returns to its starting position. So velocity was the first derivative. That's when it hits the ground. So you plug 8.06 into your first derivative. So this is just a lot of testing. Do you know where to plug things in?
No.
Do you have a copy of this?
There might be an extra one in the calc folder over there. Your test is 10 questions. There's 3 multiple choice and the rest are short answer.
3 multiple choice.
3 whole multiple choice
You
questions.
spoil us.
I know.
She knows.
Oh my